Hey, we got a phone call from an integrator customer, and it was a good example of the fact that we are often getting phone calls that aren't necessarily for greenfield designs, but the phone call is more, this isn't working, get us a solution as soon as possible. And also a good example of how many different ways there are to solve problems like this, and I thought it'd be a fun one to talk through some of the solutions we came up with on the phone call and see what you think of them and if you think there's some that we missed. So let's take a look. Situation here is there's an existing site with a compact Logix talking to a local HMI and across a narrowband radio network to a bunch of remote panels. These panels tend to have potentially a micro PLC, some point I/O, maybe one or more VFDs. And what this integrator was adding was a bunch of new remote panels over new fiber connections, and then also ignition was being added to the site to collect data from multiple PLCs. And what they were encountering is ever since they added these new fiber connections and brought up these new panels and brought ignition on board, the HMI was showing frequent disconnects, and basically it seemed like this entire radio system was going down. Maybe this wasn't a surprise because it is a narrowband radio network that is good for maybe 200 to 400 kbps on each link. And it was clear that the system had been kind of programmed around the limitations of that radio system. This PLC, the messaging to these remote panels was set up round robin. It could take up to 15 minutes to get all the way through the 80 different devices it's communicating to across these radios. So the suspicion was that the new devices and ignition on the system were just adding additional strain on this already limited radio network. And effectively the question was, how can we continue to allow this PLC to communicate to these remote panels but isolate this radio network from all the new stuff? And this is a single flat network. It's we're calling it the 192.168.10.0 network. So this PLC and everything it talks to is addressed within that single subnet. Now the first question the integrator brought to us to solve this problem is, can we implement VLANs to get the isolation we want for this radio network? And the challenge there is that this is a compact Logix PLC it's got two Ethernet ports, but only a single IP address. So those two ports just act like a little unmanaged switch. And this PLC would need to continue to communicate to everything on the radio network and all of the new stuff. So in order to do that with standard VLANs, we would need to create a second subnet and ReIP the radio network and all those devices to the second subnet. And then we would need to route between the old VLAN and the new VLAN such that the PLC could talk to all of this stuff and continue to talk to all of this stuff. And that those layer 3 interfaces would need to live somewhere. This is a layer 3 switch, so they could live there, but there's an existing 40-gate firewall. Probably makes more sense for that interface to live there, but that's not a cut and dry question. This 40-gate is managed by IT, everything below it's managed by OT, so maybe some questions about where and how to implement the routing interfaces between existing and new VLAN, but you're minimally touching either this or this. You're touching all of these remote assets and re-IPing them, and you're touching the programming in this main PLC. It's a pretty heavy approach. So as we talked through alternatives, one thing we discussed is, shocker, Josh wants to talk about NAT appliances. We had half a dozen or so choices on our lab wall of NAT appliances we could send out there, and maybe we still do the re-IP for the remote hosts, but we NAT everything to their original IPs on this side, such that you don't have to touch the programming in the main PLC. It continues to target all the IPs that it did. The NAT appliance would make sure it gets to the remote hosts. And the big thing is that the NAT appliance is providing that broadcast domain isolation we're looking for the radio network. And we could do this version with technically a new network, but as far as the original PLC is concerned, nothing has changed. Continuing down the path of trying to reduce the amount of lift to get this isolation, maybe instead of a NAT appliance, we deploy a transparent firewall. This is also known as a layer 2 firewall, or maybe you've heard it referred to as a bump and wire. The idea here is that we could install this transparent firewall right in line of the existing connection between the switch and the radio network, and just write a policy that simply said the IP address of this PLC is able to communicate with all the IPs required out here, and deny everything else trying to come across this firewall. So this one sounded pretty good to the integrator because they're not touching main PLC or any ReIP work or anything. All of the heavy lifting is really being done by the firewall. But we are still waiting on appliance procurement, configuration, ship to site, somebody installing it. So keep going down the path. This industrial managed switch from Lantronix that was supplied by us and is out there has a lot of capabilities that you may not find in every industrial switch, or maybe you only find it at a higher firmware level or license or something like that. But we've got access control list capability, so we could potentially write some access control rules about what IPs are allowed to talk to what IPs. Maybe it gets complicated depending on if this switch allows only ingress rules and not egress rules. So one thing that we did look at really was private VLAN capability on this. So not your standard VLANs that you would route between, but private VLANs. I've got a post I'll share where we've talked about this capability on the switch before, but this really did seem like the perfect application. We wanted to be able to set up something that said by switch port that this port, let's call it port number 5, could communicate out port number 6 on the switch out to the radio network. This port number 5 could continue to talk to these other ports on the switch, but none of these other ports would be allowed to communicate out port 6 towards the radio network. And that configuration change is a 10-second change in the web UI of this thing, adding a new private VLAN, moving just some checkboxes around and calling it done. And then I talked to a friend who mentioned, depending on this radio model, we knew it was a GE but didn't have the details or admin access. We looked at some GE manuals and saw there is some source filtering in there, so maybe instead of doing private VLAN here, we could just write some source filtering rules about what IP address is allowed to communicate across. When we were looking in the manual, it seemed like the only source filters were based on MAC addresses, which we didn't like as much, and we also weren't sure whether this extraneous traffic was congesting the airwaves or maybe even tipping over this first radio. So I did like the idea of moving that boundary a little bit further upstream. But those are the ideas that we came up with in about half an hour on a phone call. And as we moved through these tabs, you notice that they each had kind of less work required, less lift required, less equipment, and ultimately less time. And sometimes the ask of us is, which solution can you implement the fastest? So I'd be curious to hear what y'all's thoughts are on these different solutions to this problem, which one you think is the best, and if you think we missed any.